One way for us to simply not have to worry about the existence of corner solutions is to assume that all goods are essential for a consumer. That is, to assume that a consumer cannot obtain utility above what she would obtain if she consumed nothing, unless she consumes some of all of the goods. But even in cases where some goods are not essential, where indifference curves cross one of the axes, it's not necessarily the case that the optimal solution for the consumer is a corner solution. We will illustrate this here with the same utility function that we used in graph 6.10, but with different parameters, so that an interior solution actually emerges, even though it is possible for that functional form to result in a corner solution. We begin with the same budget constraint that we used in graph 6.10, where we illustrated a corner solution. But now we've made the indifference curves shallower than they were in graph 6.10, even though they come from the same family of quasi-linear tastes, and they still cross the x1 axis. As a result, the optimal solution for this consumer appears on the magenta indifference curve that is tangent to the budget line at an interior solution of 5 units of x1 and 10 units of x2. So what's our bottom line? Basically, we can use our mathematical optimization methods without worrying too much about corner solutions, so long as we maintain some common sense. If the mathematical solution is one that doesn't suggest any negative consumption of any of the goods, then we've arrived at an interior solution which is our optimum for the consumer. If, on the other hand, the mathematical solution is one that contains negative values for some of the consumption goods, then we know that we've reached a corner solution, and we have to use our common sense to determine what that corner solution is.